So I am here with Miller Wilt from Enabled Intelligence. Miller, thanks for taking the time. And we're here to talk about traps that U.S. government agencies can sometimes fall into, or the pitfalls they need to avoid when it comes to developing AI models. And before we start in on that rich, interesting topic, why don't you just give a quick intro on who you are and what Enabled Intelligence does, and then we can go from there.
Sure. So my name's Miller Wilt. I'm the Director of Data Science at Enabled Intelligence. So in terms of background, I was originally a software developer who turned into an AI developer. I've been working in this field for about 7 years now. I have worked a lot of different domains, including vision, NLP, and even more esoteric things like radio frequency for wireless communications. So here at Enabled, we do two main things. The first is we have a great data annotation team that primarily focuses on government work, annotating either image, video, text, can really be anything. And then I come in and lead the team for model development and model testing, as well as developing tools to assist our annotators, both in terms of speeding them up, as well as improving accuracy and quality assurance and things like that.
Great. We're getting a little bit of background, like jitter or whatever. Let me just close some of my apps here just to make sure that we're not sucking up all the bandwidth. Hang on, bear with me. All right. So thank you for that little intro. So, you've probably worked on a bunch of different AI models over the years, my guess, and you probably worked with a number that are, government oriented. So in no particular order, what are some of the, pitfalls that you see consistently that people run into when they, especially on the government side, since we're focused on kind of, the government customer. What do you see? What have you seen there that is, worth pointing out?
Sure. So I think one of the things that immediately comes to mind, given the kind of space and we adopt in, is just poor data quality. Often we'll have clients come to us who either have no data annotated, very little, or if have any reasonable number, will be very sparsely annotated. So for example, you might have like a deep nested ontology where you're looking for things like Russian MiG-29s and their aircraft, bomber craft, that sort of thing. And in their imagery, they'll have the image, three total objects when they're annotated, when they're more 20 present in the scene. And this can very negatively impact model performance, obviously, as the model is being told that the objects don't exist, but actually really do imagery. And further, it really hampers model testing since you have a good, accurate set to properly evaluate a model.
Let me just pause you there. Use the word ontology. Can you give a kind of layman's definition of what
sure, yes. Is? So ontology is really just the kind of, in terms of supervised learning that many of our clients deal with, where you're attempting to predict a label for a given input, be it an image, a piece of text, what have you. The ontology simply define that kind of class structure. So a very simple one might be aircraft versus raft, right? Whereas a more complex one could nested to one or more levels. So, and kind of sticking in this aircraft space, you might have a level aircraft or airplane, excuse me, and then under that you may have things like fighter, bomber, or cargo, and then you could even go farther under those labels and say like, okay, and actually specify the type fighter. So it might be a MiG-29 and Su-31. May get some wrong. I'm not an expert in that space.
Sure, I understand.
So really, the ontology defines what you're trying to predict effectively.
Okay. So, so let me ask a question. Why is it? I mean, there's been a lot of money, a lot of agencies, government agencies want to, use AI models. Why do they come? It seems so obvious that you would need good data. Why is it that they don't come to the table? What is it? Is it they just forget that they don't invest the resources up front? Any sense of that? What the problem is that causes this lack of good data?
I think so. part of it is that no one, I shouldn't say, very few people enjoy annotating data. And so quite often teams are composed of people like me, data scientists, and quite often they have like PhDs and other things. And then they really focus on the model and the process, right? They don't want to spend their time just sitting there pulling data. And because of that, the budgetary constraints, there just might not be the need to hire an explicit team or annotating data.
So in other words, data annotating is not sexy. It's not glamorous. No one's gonna like. You're not gonna get.
And what makes it really tricky for government in particular is that commercial people or not clients, excuse me, commercial companies will just source it abroad, right?
Right.
India.
Kenya, we saw that with we saw that with
exactly. ChatGPT is a great example. I believe OpenAI paid folks in Kenya a couple bucks an hour to do it, but for government, they can't do that because the data is generally sensitive in some way. And don't start with something like classified, which obviously you class data, which you obviously just send willy-nilly, to Kenya or India. And so really what makes it, I think, particularly challenging is that you need a team of annotator who can live and operate in the US, have citizenship, and don't mind annotating the data.
Okay, so really it boils down to, I think, sounds like one pitfall is agencies sort of, they probably sort of on one level probably say, oh yeah, we need high quality data, but they don't really allocate the resources or do the planning up front to ensure that they get there. We get the annotation done correctly. And I assume there's sort of all sorts of downstream effects. It's one of those things where, a little bad quality early on can have very, far reaching implications later on in life and as it gets embedded in the model. Is that correct?
Yes, exactly. And what further challenging is that if you have poor quality data, you really need more of it to kind of swamp out the way. So going back to ChatGPT, that's another good example in that you just scrape the entire internet. So they don't need to worry as much about high quality data, at least initially. But then they needed to bring in annotators to then kind of clean up a good set so they could fine tune it so that it could kind of act naturally in conversation, like hold a somewhat normal conversation.
Right. Okay.
And so, and the effects for that for other models is that it just will perform poorly until you can reach that critical mass of data. The alternative is if you get a good quality set at the start, you generally won't need as much data.
Okay. All right. So quality. So it's important to have good quality data up front. Are there any other things that government agencies, government customers, or any customer should be on the lookout in terms of AI model design, et cetera?
Yes. I think the other big comes to mind is a discrepancy between the training data and the operation data. So yes, a lot with government. I'm sure there are examples with commercial companies as well. But given that a lot of government data can be very sensitive, even classified, quite often what you'll see are teams who will use open source, at least unclassified data, perhaps purchased from commercial companies. Perhaps get that annotated data, or it was already annotated if it was a public data set. They'll train their model on it. It'll perform well on that open source data or unclassified data, but the second they bring it into a SCIF and throw it at their optional data, it performs incredibly poorly.
Right.
And that's unfortunate. Fortunately, due to the fact that deep neural networks are incredibly powerful, they also are very prone to overfitting and as well as struggle with generalization outside of the training set. Unless you can get to a massive amount of data that you might see in like NLP or natural language processing stuff. Given that a lot with vision, computer vision use cases, you don't quite get to that critical mass. It generalizes to everything, and so that's usually where things that transition from training to operationalizing a model.
Right. Okay. So I think being aware. So there's got to be some awareness that being really careful about what you use to to train your model
Yes.
essentially is really important. Kind of that awareness
Exactly.
and so on. Okay, that's a good takeaway.
And it can even be as
Yeah.
just to add a little, there can even be as subtle as different different like locations. So let's say you train on data from, I'm just going to make it up, from Houston, Texas, but then you want to deploy it in Beijing, China. Very likely it's not going to work from that transition. So you need to
Right.
really be careful, as you said, to ensure that your training data really as closely mimics where you're going to be deploying it as close as possible.
Wow, that's great to know. And I assume, to put a plug in for enabled intelligence, that I mean, one of the values you bring is sort of a little bit of that quality assurance in terms of sort of like, hey, you're having us annotate this training data, but have you thought through whether or not it's, appropriate for the model that you're ultimately going to be testing on, and so on. I assume that's kind of some of the real added value you're providing to customers.
Yes, that is one of many things. But yeah, we work closely with our clients, and throughout the entire process. If they just want to annotate data, we'll work with them to annotate the data, find edge cases, talk about how it's going to be used, their own model tree, to make sure that it is relevant for what they actually want to use it for.
Okay, great.
Related as well is that we can in that we support annotating at classified levels. We really make sure that we're annotating data that actually models will actually be deployed on.
Okay, let's try and go. I think I'm a big believer in the power of three. So we've come up with sort of two pitfalls so far, maybe a third, and this gets to is there anything, a hot topic in my understanding about AI is the issue of sort of auditability and and kind of understanding how the model works and creating something sort of really to have some sense of it's not a complete black box, if you will. Is there anything that you've seen that that again traps or pitfalls that agencies and customers can avoid to kind of ensure that they have a more auditable or understandable model when they finish this process?
Yes, absolutely. So I think the biggest thing I've seen is much trust in the summary metrics, and this is even a trap I've fallen into. I think it's easy to do so, where you will train a model, you have a good training set, a good test set model, you run it through its paces, and you throw your test at it, and you get no, right? For object detection, if you're dealing with object detection, that may be mean average precision, could be like perplexity for NLP, or just accuracy. And then you'll be like, all right, high number, or depending on metric, low number. It looks good, and you just ship it out. The problem is that can hide failure modes in your model. So it's very important to visualize some outputs, right? Because then you find potential issues, either you have an object detection model and it's consistently classifying fire hydrants as an object of interest, like a car. It's important to recognize those things. And then relatedly, there are tools out there, and we offer some, that help with being able to parse out your data into subpopulations and actually measure performance across the subpopulations. So
that would be good. Yeah. So you're disaggregating, so you're not falling into kind of the trap of averages, looking at an average.
Exactly.
That hides some terrible black swan, which could result in sort of some terrible outcome.
Yeah, exactly. And quite often data sets will be balanced. So it's particularly important to look at those classes or objects that have that appear very often.
Right.
Because your model is much less likely to perform well.
What about so that gets into, in my opinion, we talked about testing. We talked about, obviously, testing in a sense is the ultimate quality assurance, if you will. Or is there anything else from a quality assurance standpoint that customers should be aware of as they look at, as they analyze the effectiveness of these models?
Yeah, so I would say the other side would be on the data itself. So making sure that your data was annotated, you had a good QA process involved. Annotators are human. Even if you employ like something like model assisted labeling, which is driven by a model, that's be perfect. So there's going to be errors in your initial labeling process. So it's important to have one or more QA layers involved to correct mistakes.
Okay, so the pitfall would be sort of, make sure to build in, don't fail, avoid the pitfall of not building in adequate QA early on in the process, it sounds like.
Exactly. Yeah, it needs to be kind of throughout the whole process from raw data all to model output, because any failure along there can influence downstream performance.
Okay, great. Well, let's pause the recording there. I think that gives me plenty to work with, honestly. Okay, Miller Wilt, resident expert data scientist at Enabled Intelligence. Thank you for talking with me today. I'm going to start with a real simple question about AI models. We hear the term AI model training, and then we hear the term AI model testing. So for those who need to know and who've been afraid to ask, can you just kind of explain the differences between those two concepts?
Sure. So much of AI today falls under something called machine learning, and the idea is basically, can we kind of take some of the concepts that apply to humans? If we want to learn, let's say acquire a new skill, we need to practice, we need to learn, and can we apply that to artificial intelligence algorithms? So training refers to that process of an AI model effectively learning to do the task you want to do. So a very common task in computer vision is object detection, right? So you're attempting to both classify and localize objects. Rough example might be find all the cars in a scene, given an image.
Right.
And so you need to train that algorithm to do that. And so traditionally, the way you do this by something called supervised learning, where you have an annotated data set. So this the car example, you'll have a whole bunch of images with bound boxes or annotations specifying where the cars are in the scene, and you'll feed that in a model with the labels, which then you'll use to effectively, long story short, learn how to identify cars. There's a lot of more complicated processes involved in that.
Right.
But effectively, it uses those labels to learn how to identify cars. This could be contrasted with kind of good old-fashioned AI, which was largely based, and there really wasn't any learning involved, right? Just had kind of if-else statements to simplify things. Now, testing, on the other hand, is really kind of analogous to test students in class. You want to validate how well your model learned the concepts that you're trying to teach it. So going back to the car example, what you would do is you would hold out a set or validation set, depending on where the process you are. And it's important that the model never trained on this and never saw it.
Right. Sure. You want a completely different. Yeah,
exactly.
Back to the homework example, you don't want to give the students the same the questions you gave in the practice set. You want to give them new problems.
Exactly, right. To test this idea of generalization, right? How well does it truly understand the concept that you're attempting to teach it? And so then you feed it pulled out set, and you don't give it labels. You just feed it the imagery or the text, whatever you're dealing with, and then it spits out what it thinks it is. So it may think, for the car example, it should hopefully identify all the cars. You can then use the predict outputs and compare it to the ground truth you have in your test set.
I see.
And then quantify that numerically in some way. So for thing like object detection, a very common metric is mean average precision. And so you could use a set of metrics to then kind of, as I said, quantify how well the model's doing.
Okay. That's great. Thank you. And just to put a little plug in for Enabled Intelligence, you guys provide data annotation, data labeling for essentially the data sets used to train AI models. Is that correct?
Correct. Right. Yeah. You generate very, very high quality data sets for both government and commercial clients, we also model development and model testing. So you can come to us for frankly any part of the
Okay.
machine learning lifecycle.
Great. All right, perfect. Thanks, Miller. That was excellent.
Thank you.